Hi, this video is about a project for creating an automatic vehicle license number plate recognition system that could have a number of uses, such as for allowing emergency vehicles through, perhaps opening gates or alerting or taking any action really, perhaps based on allow or deny lists of certain plates. You could even identify suspicious activity, such as vehicles circling around streets or premises repeatedly or at certain times, and send an alert. There's just so many actionable things that you can do when you've inferenced valuable information like that, locally, in real time from the real world. To get there, I needed a system for running AI models that can detect vehicles, license plates, and the characters that are contained within them. That needs some hardware AI processing resources, and fortunately there's an edge compute accelerator card specifically for AI called Metis by Axelera. It's got a high-speed PCIe interface, and it can be installed on x86 or ARM hardware. What's really neat, one of the great features, is that it is supplied with a software development kit which supports Python as well as C or C++, and is claimed to be easy to use, and it turned out, in fact, it is. Part of that is due to the fact that so many trained models are available with the SDK, and they can all be run with very little coding because they are described and configured through text files, human-readable YAML basically. That means that the coding effort can be as little as connecting video sources into the stream for inferencing based on any of those, or your own models. And at the other end, some code can be used to display the output, or onward process it. First off, I connected the board to a USB webcam so that a /dev/video device file in Linux could become the video source. The ARM single board computer doesn't have a lot of storage space, so it can be worthwhile to install some additional local SSD storage. Plus, while I was at it, I fitted a wireless LAN card, although that's not essential. A key part of the project was to be able to control gates or provide information on LCD screens, so I used the RS-232 connection on the SBC and wired that to a microcontroller, a Pi Pico in my case. If the SBC you're using doesn't have RS-232, it's possible to buy USB adapters to add that functionality. The diagram here shows a proposed solution to capture a video stream on the left side and ultimately act on the license plate text on the right side through the use of a microcontroller. In between, it was decided to run 3 models, known as a cascade, in a single pipeline using the Metis accelerator. The first stage uses an existing model called YOLO, or YOLO V5 in particular, trained on a dataset called COCO, which can identify 80 different types of things such as animals and objects, and fortunately various modes of transport. For a first attempt at this project, it was felt that this would be a good choice because it's a decent object detector, more than capable of recognizing vehicles at reasonable performance, and it's already available as part of the SDK in what is called the Voyager SDK Model Zoo. Running it is extremely simple, literally one line to execute, passing in the video source. The reason it's so simple becomes clear later because the inferencing pipeline is actually described in a YAML text file. I set off and grabbed a load of video around the town to apply it to the system, and it worked as expected using supplied code called inference.py. I actually ended up creating my own code based on that, but there's actually no need because the supplied inference.py is sufficient. My code just adds some checks and is intended to communicate to the microcontroller ultimately. So that all worked, and now it was time to think about the next stage for license plate detection. I decided to again use a YOLO model, but this time tweak it for a license plate dataset, which I found online at the RoboFlow website. The training takes quite a long time, so it's best to use a cloud provider. I ended up using Amazon Web Services. From there, the model, in standard Onyx format, can be placed into a folder in the Voyager SDK, all ready to compile into binary code for the Metis card. I also needed to work on the pipeline. I took the YAML file from the first stage and then added the second stage detail to it to produce a 2-stage cascade of object detection. There are example YAML files in the SDK, plus the file can be validated by typing make help, which lists all of the YAML files, but only if they look valid. It's a quick check. I actually still needed help, but there's an Axelera online community, so I placed the question there, and the excellent responses helped me move forward. The console output here shows the deploy command being executed, which compiles up the model for Metis. It took about half an hour. You're watching this sped up. And once that's done, again the same inference.py can be used. For the third stage, the plan is to use a model called ALPR-net, which should just fit in, but that's work still to do. I actually worked out of sequence, so the remainder building blocks on the right side of that earlier block diagram are complete, and it's possible to send license plate text to the microcontroller and for now display it on an LCD screen. Currently I'm just sending random text values as a test. There will be a part 2 video to cover the remainder small detail for the missing third stage. I'm actually excited to see this work because I do have some applications in mind for it. I hope you enjoyed seeing or also reading about this project, and please stay tuned for the next part. I want to thank all the team at Axelera for their kind support. Thanks for watching.